Okay, so let's take a look at this other example now, where instead of looking at the function that maps the reals to the reals, what if we just restrict it on the positive, or the non-negatives, maps to the non-negatives, where we still deal with x squared? Is this injective, surjective, and or bijective? Okay, so again, want to build intuition about injective. So if we look at different outputs, if we look at outputs, will there be two elements in our domain that get mapped to the same thing? So if we look back at the previous example that we did, well, we use a lot of negatives in that counterexample. So in this case, we end up trying to show that it is injective because we don't have to worry about the negative case. So we will prove that it is injective. So what this looks like is going to be much more like a proof, like I said. So we're going to state here, let x and y be elements in 0 to infinity. And I'm going to clarify that this is the domain. Just because the domain and the codomain are identical in this case, it makes it a little bit easier if you specify, I'm talking about these elements being a part of my domain. Okay, then what we can assume here that if we're just going to do a direct proof, if f of x equals f of y, then we're going to try to show that those are equal. So we will assume f of x is equal to f of y. So we just start with that first part, and then what this is going to imply then, if what f of x is that's just simply x squared. And what f of y is that's just simply y squared. So this assumption implies this, which then we have to be careful because when we take square roots, if you forget about the positive negative, then you would have on the previous example not had a counterexample. So we want to be careful that we take the square root of this. So this implies that x is going to be equal to plus or minus the square root of y squared. So this says that x is equal to plus or minus y. So we do the math correct, that this is exactly what it says, but now we say, wait a minute, these are all non-negative numbers, so these have to be the same sign. So since x and y are in 0 to infinity, it must be the case that x is equal to y. Now, obviously, unless it's 0, then obviously that could equal the same, it equals its own negative, but indeed, it's still true that it is equal to the same. So indeed, we have now shown that if f of x equals f of y, that implies that x is equal to y. So we have shown that f is injective. Now, to work through the surjective, again, we want to think back to what is the intuition behind surjective. So surjective says that every element in my codomain has an element from the domain that gets mapped to it. So now if you're looking at only positive numbers, the counterexample we did last time does not work for us. So we're going to be showing that this is surjective. So if we try to show that this is surjective, again, we want to start in a very similar way as a proof, right? So we're going to pick an arbitrary element in my codomain. So we're going to say, let y be an element of 0 to infinity, which for clarity, we're saying this is the codomain. So we pick an arbitrary element in my codomain. Then we'd like to figure out what is the value of x that when I plug it in, I get that equal to y. So we will now, because we have to consider for all y there exists an x, I just have to figure out what is that x value. So let y be this. We will then state pick x is equal to the square root of y. So this is our choice that works, right? So we know that this is the case. We don't have to try to do any arithmetic. We don't want to be doing that in this case. So we want to now verify that this x is in the domain and that f of x is equal to y. So there's two things. So be careful. If you're not verifying that this is in the domain, then you might be coming up with something that's not true. So pick x is equal to this, since y is greater than or equal to 0, we know that x is an element of 0 to infinity. So basically what I'm stating here is that since y is something that is positive or 0, so it's non-negative, we can take the square root of it and it's well-defined. So then x is a well-defined number, and it's also something that's always greater than or equal to 0. Now we verify the second part, that f of x is equal to y. So now notice that f of x is equal to f of the square root of y. Since x was the square root of y, plug that in, we have equal to the square root of y quantity squared, which we know is equal to y. And so this is how we know that this is a surjective function. We have just done one of these quantifiable proofs, and it verifies the definition of surjective. So we'll take a look at some other examples of what if we start to kind of mix and match the last example with this example and see what does this look like if we change the domain and codomain a little bit more.